Yes, thanks for the kind introduction, Fatima. You almost described SCS, but first of all, thanks for giving us the opportunity to be here today and to speak here on the Fitness 2 event and forum. Yeah, Styrenic Circular Solution, maybe starting with myself. My name is Jens Kathmann. I'm heading this as Secretary General. This is French, English wording because we are Brussels-based. As Fatima expressed already, we are a value chain association. So we are covering the full value chain from monomer, polymer producers over converters, recyclers, brand owners. And in future, we trust also retailers to best have the outreach to the end user. Yeah. And this is what it's all about. It was mentioned also Intraplus. Yes, Intraplus Portugal is an important member. And in general also it can be said that the converters are a crucial part in the value chain, especially in packaging and polystyrene. But same is for PET and for polyolefins, what you already heard today. And next to that, the value chain is also the key for circularity in our opinion. And I think this goes without saying. It was mentioned already, as well as recyclability and circularity are two objectives which are somewhat ultimately linked, next to also sustainability. You have to be first in a way fully recyclable in order to move into circularity. You heard a bit on closed and controlled loops and to somewhat have, for instance, good example, PET bottles in multiple times being collected, sorted, recycled, again going into the waste stream, being then again collected. So this is what we also do. And what you see, to stay a bit on this slide, and starting with our narrative, you see here a lot of food, you see young and older generations. When we started, we are just more or less 4 years old, we started 2019 back. It was really important to immediately catch up with recycling technologies to somewhat prevent our materials, which at this stage more or less completely went to incineration and landfill, to get these materials back, our molecules back out of the environment and back into recycling streams. But we also decided amongst SCS and our management to say we directly go into the packaging, and there we go for food, which again, you can say and have learned today, this may be the higher art and state of the art of recycling, but any kind of downcycling, any kind of non-food or let's say lower value recycling in order to really catch up with our activities, what not on the agenda. And this forms a bit the narrative I was mentioning already, that we said, okay, we will apply game-changing technologies in both recycling, collection and sorting. We will also then use these efficiencies which we have in purification. Again, a good hint is what we heard on Fraunhofer already on purification, on challenge testing of materials to really ensure what we all have to be. And therefore, again, you see this young girl also, this 150% safety, as I always say, if you go into food applications, that you have a consistency, a certain high-level quality, and also again and again in multiple loops, in a controlled loop recycling, really is this assurance that your materials are safe. And having said that, we are also jumping back a bit to the regulation, which was mentioned already, the new regime by the Commission 2022-16, because here the safety of food is really the overarching ambition and target. So let's see. So to continue a bit with the narrative I mentioned and those technologies and game-changing technologies, as I said, if you see on this table and you start on the left, we come from the market. Polystyrene is compared to PET or polyolefins comparably a smaller polymer. But again, if you break it then down to food contact, food packaging applications, which you see on the volumes here, more than 800,000 tons in Europe, you see there's a shift of importance also if you really limit it and focus on the segment of food packaging applications. Also, what is good in this food contact applications, as you see, and as I said before, this sortability to really get your molecules back to, if you want, individually even sort out the yogurt pot or vending cup from the mixed waste, this was really something, a good basis to start with, where we said, this somewhat is done. Then you see in the middle 3 technologies. Again, those were partially mentioned: chemical recycling, depolymerization. We learned about Creasolve. So if I just mention our technologies here, you have the high purity mechanical recycling. This is also what we did and still do very successfully in the beginning with our activities, but we also have the dissolution. Creasolve was mentioned, so it's a solvent-based purification process. Both technologies stay on the physical level of the polymer, so it's purified either by washing processes or in the dissolution via the solvent and the sedimentation of the bad actors and the purification of the polymer. And the depolymerization, I think, was also mentioned. There we go back to monomer. That's our chemical recycling. Yeah, that's our chemical recycling, I always say, because it's for the time being. You all know the big scale chemical recycling is yet to come. There's still discussion ongoing on the European level, because for all those technologies, but most important for the chemical recycling, it has to be at scale, and it has to be also on economic levels. That is highly important. And then, of course, for the big chemical recycling, still other parameters such as fuel and energy consumption and all those, let's say, criteria come into play, which somewhat still up to date does not give you a fully regulatory-based, let's say, firm direction and future for the chemical recycling 2025 and beyond. This is important because our technologies, they are all technology readiness level 9. They are in the market. You have depolymerization in the market in France, in Belgium, going already forward and applying this technology. You have dissolution also being applied by members of SCS in the field such as Transeo, for instance, but you also have heard from Fraunhofer, a lot of activity is ongoing there to really drive the purification towards, again, food contact. And the depolymerization, as I said, we have it also already in the field and scaling up over time up to 25. There's already a nice investment plan of our industry in order to deploy those technologies. And again, they are all 9+ in a way already being deployed and then being scaled up over time. On the right side, this is a bit the conclusion on the narrative. What is the output? You can see that there. We have basically a drop-in solution, so our virgin and our recycled polymer is behaving absolutely the same. So looking at converters such as Intraplus or others, they really can somewhat switch between or compound both without any change of processing parameters. That's a great news, I think, for any converters, also from the complexity and cost. On the other side, this freedom of design, I'm coming to this later on a specific slide. We have mainly mono materials in the market. Predominantly they are white or virgin natural. We don't have any colors. We don't have that much black, carbon black colors. So let's say the sortability, which I mentioned, and the color of the material, and also the purification and collection sorting by near infrared, for instance, is really pretty easy done, and again, also on a safe manner. And what you see on the last part, I think it has been mentioned as well, this novel technology, the new regime, gives you basically 2 new situations. One is, of course, you have to apply for novel technology via a competent authority in your member state country, then to the Commission, and afterwards then it will be checked by EFSA. And the second part, which is really important, is that you can start market after approval immediately your materials. And over time, minimum 24 months, your technology and your processing parameters, your data will be monitored. And more or less in a magnitude of 24 months minimum, you get then the approval to a suitable technology. That's new, and it sounds in a way fantastic. Marketing more or less immediately after approval over time. On the other side, as I said in the beginning, watch out, novel technology on the way to suitable technology, zero failure rate, it has to be really 150% food safe, it will be monitored by EFSA and the competent authority, and the Commission is approving, but also approval can be withdrawn over time. We are pretty confident that we can do it and that we manage. On the other side is something we are just starting. SCS has somewhat put the role as a developer. We have notified our first novel technology end of last year for ABA. I'm coming to details on ABA and what it means later, what this means in practice. Having said that and looking on technologies, and already I somewhat hinted towards chemical recycling. If you go on this slide a bit from the, in your turn, right to over left, you see a bit the sorting collection I was already expressing on. There's mixed plastics waste, there can be a controlled or closed loop, means even individually the yogurt pot or the vending cup in order to collect it really in a very controlled manner and bring it to recycling. For the mechanical recycling, the thumb rule is the more you slice precisely your waste stream and collection and sorting, the more easy it is then later on the process. But again, via washing, via degazing, there are technologies in order to purify the material also with, let's say, percentage of maybe 5% of non-food, but still going to then food applications. The dissolution is more or less on par with the mechanical recycling. There it depends also a bit on the input materials and the solvent used in order to manage your contamination and decontamination processes. And the depolymerization in the center on the left is the last one, back to monomer. It gives you the toolbox from the monomer, styrene monomer, no mass balance to somewhat polymerize in various PS grades and types for various industries and application. So it gives the best and multifold, let's say, opportunity with depot. But right now, and I think it has been said also, a lot of activity is ongoing in the mechanical recycling, and I'm also not shy to say that we are, in a way, a bit very similar to PET, from the testing, from the mechanical recycling processes, from the challenge test, which was mentioned already, from the low diffusion properties of our polymer. It's really nice using mechanical recycling either in mono or in ABA solutions for food contact application. And there are basically in Europe right now only two materials performing this role, which is PET and which is now getting on board is polystyrene. We call this plastics to plastics recycling, and last but not least, on the outer left side, we can and we are suitable for chemical recycling, for mixed plastics waste in future. There's no constraint also having polystyrene in this mixed plastic waste stream, but from the, let's say, food contact opportunities we are holding from the technologies which are already ready, and from the fact also that we are accordingly to the big blocks, polyolefins and PET, a smaller fraction in this, we have decided to immediately move with the center, means using our plastics to plastics technologies already right now. This was mentioned as well, but we also thought about this life cycle assessment LCA, CO2, ideally, let's say, zero carbon in a way that you really have a carbon neutral processing of your materials. You see here, based on the technologies I just mentioned, what are right now the CO2 savings for polystyrene technologies. The leader of the pack in a way is of course the high purity mechanical recycling. So combining the economics, cutting off, let's say, in the loop, a significant proportion towards the fossil production, and the mechanical recycling plus the CO2 saving is really one of the winning arguments why many people right now look towards mechanical recycling. Yeah? For polystyrene, but same, as I said, would be for PET, in order to really catch the momentum and become carbon neutral and comply also to other EU regulations like the Green Deal and, let's say, what I said earlier, the sustainability aspects of our recycling activities, which are very important. Dissolution and depolymerization are more or less equally 70 to 75%. For the depolymerization, a fair statement is that the scaling up is not fully incorporated here, so we see upsides from scaling and depolymerization from, let's say, a larger scaling of the plants. And the last point I like to say, because LCA is always challenged also in a way, we did our LCA against the, let's say, incineration and the virgin production step, which is absolutely fair to do. And we mainly looked for the CO2 savings at the fossil depletion, again, comparing then for the virgin production and the global warming potential, which is also a major part of the discussion on CO2. We also included toxicity and water management and all that coming from the ISO standard, but basically in order to derive those CO2 savings, we looked at these two major impacts in order to calculate those figures. And again, some scaling should further level up those percentages. So this is really good, and looking at this low carbon footprint, and what we do is in a way of somewhat then going next to the purification on challenge testing and purification of materials. I mentioned basically those purification steps are done in two ways, or two objectives. One is for the direct food, and one is for the ABA. It somewhat always directs into the contamination and decontamination and cleaning efficiency. For the ABA, you can also use it to prove the effectiveness of a functional barrier in order not to keep it too much on the result. The functional barrier properties of polystyrene are excellent, so you can use it in the B layer. But of course, we do this exercise in a way also to use in the B layer recycled materials to again have those systems, those composites then going to the recycled loop multiple times. But in a way, how the challenge test was done, you can see it here in those steps. You see the flakes, the purity, already the color. So color, as I said, mainly white or virgin is not the big issue. Some people even like to see that it's recycled material, for instance, brand owners, but it can be really white, maybe not the standard white of the yogurt producer, however, it will be very white. We worked with partners NGR and Gnois, but there are others in the field in order to comply with competition here. There's Starlinger, there's Kraus-Maffei, so you have more or less multiple choice of those, let's say, companies via extrusion, via, let's say, gazing, vacuum, somewhat purifying those materials and decontaminating those flakes and coming back, number 3, to nice white pearls, granules, more or less similar to virgin, which you then can use again for your recycled loop, either in 100%, so this Gnois and NGR. Important argument is you can go up to 100% recycled content with those materials. So the performance, as I said earlier, is a drop-in. It's one by one like the virgin materials. But of course, right now in the building up, many people are happy to somewhat use 20 or 30% of recycled content. And we learned a bit on the pricing parameters in PET. So we aim already in order from the feedstock management not to come too much in those situations that the recycled material is overshooting from availability and pricing the virgin market, because this should at least reduce the ambition and the acceleration, and we don't want that. ABA, for those, again, who are not that familiar, as I said, ABA means there's a B layer in the middle and two outer layers A. The outer layers normally then are virgin material. The middle layer is then made of recycled material. As I mentioned already, from the low diffusion, but also from the functional barrier properties of our material polystyrene, this is absolutely safe. Yeah, and basically we did those tests between 40 and 50 microns. To those of you who might be interested, what is the thickness of the layer? 40, 50 microns means it allows you to put up to 50% of recycled material in the system in the B layer, which again is more than you need to do right now, and most likely what is available in recycled materials. However, gives you a bit of freedom of operation to know ABA is really one step towards circular polystyrene. The other step, as I said earlier, is a direct food contact. This means mono, but mono also in a way that you can compound 20%, 30% of recycle with virgin material, but then have a mono system based again on all the properties of polystyrene, which are somewhat excellently performing your circular ambitions and your circular requirements. And this all can be placed already on the market. So we will somewhat finalize the initial report and the final report to the Commission via the competent authority by 10th of April. Then we have to see how fast we get in either receiving approval and or getting questions by EFSA on our processes. Again, I like to positively mention Fraunhofer here. We have done a lot of work already in this field, so we are really confident that we can do that. There will be also, one is already out, another one, ABA, is coming, 2 articles by one of the Fraunhofer employees, Frank Welle, on all these technologies. So for those of you who are interested, there are a lot of data on migration, on decontamination, and all this, what I'm just flying over here right now, will be mentioned in those articles, which can be then, I can share the link here via Fatima. It's highly interesting, multi-page, very deep dive into the technicalities of polystyrene recycling, but again, it will also be part of our circular ambition under the new regime 1616. The converters, the drop-in I have mentioned, converters I think for us, as I said, crucial as the value chain, they're part in the value chain, and when I earlier on went a bit quickly on 40 or 50 microns of layer thicknesses, this is highly recommended to have converters in the testing involved here, because to maintain an equal thickness level and an ABA system solution over time in extrusion, this is the good news for us in a way that we have good converters such as Intraplus, but also others in our field, Acoexpan, Agriner. We have them with us, Pacor, to really work together in order to implement those ABA solutions. And those arguments from the converters, but also back from the market, you see on the right side, I'm not reading them all. It's, as I said, basically in multiple cycles, no degradation. It's somewhat from the color and from the behavior in FFS form, fill and seal, absolutely the same. And maybe only on the yogurt, second last, and the very last one, which is very important, is just, and you might know that, in multi-packs, if you then crack or somewhat portion the multi-packs, you have to have this nice nabbability that you can remove your yogurt pot from the 4 or 6 row in order to get just one yogurt pot. This is really something which is, yeah, maybe the most important requirement in this multi-pack, let's say, application, and polystyrene, we are very happy, is doing this job also amongst the other criterias. So this is on our, let's say, narrative and where we got, and now we are really with the ABA, SCS developer. We built our own consortium right now for ABA, for both the Article 10, but this is detail level, for the immediate market approach and also for the general ABA approach. We have not decided yet on the direct food, on the mono applications, but I see need coming in a way. However, ABA right now is our mission. And looking at other areas, just to give you some examples, I mentioned the yogurt pot. We are also doing this for the vending cups. And we also have in XPS the trays. And here you see how those consortiums and, let's say, alliances of stakeholders are built. I think Tomra, the name was already somewhere also popping up here. We have Corolla, which is then the sorting, collection sorting major in Italy. We have Forever Plus, this is a recycler. And we have Versalis as a producer, and at the end also Magic Pack. So you see a bit like in SCS, the value chain working together. Why you have to do that, especially under the new regime. In particular, Forever Plus as a recycler has a very crucial role on the decontamination, on ensuring, let's say, the safety of the recyclate or the flakes in a way. And then, of course, for the compounding and towards the end user, Magic Pack is somewhat the brand in XPS, but also for the, and this is important or not important to know, let's say for the pre-processing, Corepla, Tomra, pre-processing, including Forever Plus, processing, and then the post-processing, comes then towards Versalis and the magic pack for the filling and for the selling of the materials to the market. So ideally, you see the full value chain, the full process here embedded and reflected on this consortium, and so this is somewhat what we see in the near future building up. We have a similar thing in France, if you know the PS25 on a more general level, and we are working in Germany, in Belgium, in Austria. Spain is coming up on those consortia in order to somewhat operationally implement polystyrene recycling. For recyclers and for standardization and design for recycling, and I speed up, I think my time is coming to an end. We are building on the excellent uniqueness properties of polystyrene. I mentioned some: low diffusion, predominantly white. It's basically mainly monomaterials. This does not mean multi-layers are bad. However, we are very much already in the mono area, which somewhat facilitates and eases a bit the recycling processes and also the steps. We are doing just now and finalizing again with Fraunhofer a misuse study in order to also demonstrate and showcase the purification of our materials. So what will happen if in any 10,000 yogurt pot somebody would put a fertilizer in, and this will go back into the recycling stream, means what is the impact on the overall quality of our recycling, of our recyclate. This is more or less finalized, but very important also for the new regime. And other things, as I mentioned, this basically easy sortability, processing, near infrared, again TOMRA was mentioned, and this multiple loops and no degradation is part of, let's say, the value add of polystyrene in recycling. In summary, on recyclers, on green, on having already positive recyclers approvals for colored containers and soon for a circular yogurt pot design and more to come. And also on our circularity matrix, because it's not all food to food, it can also be food to non-food and in those directions. So in feedstock, let's say, applications, you can look also what else is in the market, SVF, also polystyrene, XPS and EPS, but all goes to the full circular, let's say, performance of polystyrene, predominantly, again, takeaway in food, and building on the strengths, I think, as I mentioned already, and this also will help us to comply with the European strategy for plastics and those recycled content targets we are facing and have to meet by 2025 and beyond. We try to outperform, to overachieve, but again, looking at European-wide and knowing there are some areas in Europe we have learned also from the paper, let's say, presentation that this is for all over Europe quite an exercise to ensure all those recycling targets and their, let's say, achievements. We are happy if we, of course, can comply to the strategy and achieving those targets. Yeah, that's the summary slide. It could have been at the beginning, but also at the end. We have those data, we have those proof points, as we call them. The missing ones together with Fraunhofer and or from our value chain are just provided. We are already in the new regime and having notified in novel technology. There's more to come with regards to consortia. The recycling technology, they are all technology readiness level 9, so they are available and it's more a matter of scaling. And from the proven, let's say, performance, we are now very much in the acceleration in the supply chain, in the feedstock building in order not to run into shortages, and also while delivering now on design for recycling and standardization and joining more brand owners in our ambition really from the value chain outreach towards the end user, what is then the final objective, that the end user also perceives recyclability, sustainability as this important for the future in order really to contribute to sustainability and do something good, not only for the environment and getting molecules out of the environment, but also doing very good for next generation and having sustainable, let's say, behavior positively. This is really our ambition, which we somewhat do in the plastics group with PET and polyolefins. Yeah, this is it. Thanks for your attention. I hope it was not too detailed. Yeah, But this is where we are right now. And if there are questions, happy to answer.
Thank you for the presentation. My question is, so you mentioned a couple of times the closed loop recycling, but this is still, you mean the post-consumer waste is included, yes? Because as you probably know, the new regulation on recycled of plastic in Kathmann materials are very strict.
Yeah.
They define closed loop only when the packaging is not reaching out to the consumer, but I just wondered, you involve the post-consumer waste, yes?
Yeah, we are right now in the post-consumer, building also on the experience and what we have achieved already with the yellow bin. Or if you look next to Germany, to Belgium, Plus, or I mentioned also France, where this collection sorting is ongoing. But I like to somewhat mention, but this is in discussion also with the Commission for the new regime. There's always a yellow bin, and then there is a mixed household waste, which is somewhat called the gray bin. And with regards to the capabilities of our material together with TOMRA, we are also already delivering studies on getting plastics materials, because there's quite a substantial portion in the gray bin, unfortunately, of plastic materials, to sort those materials also from the gray channel. But this again is on the future. You're absolutely right. Right now we are in the post-consumer area with the yellow bin and those collected post-consumer materials.
I have a question, if I may. I think you mentioned it, but I don't know if I understood correctly, that because for PET, very long time ago, there was a study on the contamination level that was observed in the market. Is there the similar study being done, or it was done already for polystyrene? Or it's in the plans? I didn't understand.
Yeah.
Yeah?
No, good question. And again, I had it maybe too short on the agenda with the misuse study, which is part of the new regime, which comes together with the fact, same as for PET, that polystyrene has a very low tendency to absorb materials either from the outer side, means by any kind of non-compliant, non-conform printing inks and those things, or glues, and same as for the food contact. But in order to demonstrate this, I would say zero contamination from the decontamination of our materials, we are just doing this, and I think next 2 weeks it should be finalized, this misuse study, where you use really a hammer, to say so, from the content, using the fertilizers in order to somewhat then later purify, decontaminate, and then also demonstrate that this has no impact on the food quality of materials. But again, it's a bit also a statistical approach, but it's one by one the same as for PET. For a PET bottle or a milk bottle of polyolefins, it's absolutely all the same.
Yeah. And of course, and I don't want to continue the conversation because, this level of misuse, of course, depends on the consumer awareness of how to properly handle a packaging that was used but is still a valuable material to be recycled and so on. And I wonder if today the consumer has the same behavior that used to have 30 years ago, where the other PET, yeah, I think maybe not, or maybe worse, I don't know. It's for discussion, maybe tomorrow.
Yeah, I would say this is a bit still maybe not fully open, but at least the final objective, the consumer behavior, the role of consumers in collection sorting. Look in Germany, what you find in the yellow bag and all that, that people really understand. It's important to at least look, is there a 6 for polystyrene, and is it maybe something which is non-recyclable, and maybe aluminium is different from plastics. This is something we are working with all together with plastics, but in general, and maybe to the extent also is a part of the regulatory environment in a way that you say, hey, we have to do more. And it's not the solution, as we know, to print too much information on packaging, because first of all, no one is reading this, mostly because there's no time. And secondly, we have to find really from that other ways to improve collection, sorting, consumer behavior. And I think it goes also along with the scaling up with more recycled materials in the shelf, to say so, to not have maybe this, what we still have today, a bit fragmented, recycled, non-recycled, maybe different pricing also for recycled materials, all that. There's still some, it was said earlier, I think, more than 1 mile to go. It's more than the extra mile. But this is the end which we have to achieve, and I think, again, also here, brand owners, retailers, who yet in many aspects still have to find themselves in their role in recycling and circularity, what they do as marketeers and pushing materials to the market and taking back materials and maybe deposit systems and whatever we will have in future, we still have to continue the discussion on that. This is by far the final objective. If we have the end user and understood and somewhat mission accomplished, I think this is still some years down the line. But important, absolutely. And we can all contribute in our small microcosmos in order to get it better.
One time we speak about the polystyrene. Have you information about the EFSA styrene classification?
I didn't get this totally from...
Sorry, I repeat. One time we speak about polystyrene. Have you information about what kind of classification that EFSA do from the styrene? Because it's a CMR substance.
Yeah, if I got it right, otherwise raise your hand and say it wrong direction. Yeah, I heard EFSA and what kind of examination and analysis, and it was on one slide. So I think in the new regime and the former regime, the 282 2008 and 2008 tells a bit the story how old it was. However, we have now a new one, and the ABA, which not even was included in the old regime because it was in 10, 20, 11, but forget all those details. The work of EFSA and the analysis of data has basically not changed. So we can transfer a lot of data we have gathered from our challenge test, from our earlier, as PET also did, the EFSA petitions, followed by an EFSA opinion. And to stay with this old process, finally, in the old world, 282 2008, the European Commission should have given then approval. This, in practice, I think never happened, Michel, or maybe hardly, but let's not blame and shame. Now we have a new regulation, and there we have to say, next to what we have from EFSA petitions, from PET, or now also polystyrene, also I think for the new novel technologies, from the variety of recycling technologies and ABA and decontamination, for the time being, in order to be safe, you have to do your decontamination in any case, regardless how nice your functional barrier or your monomaterial is working. And also I would say, also for EFSA, and in the process, it's still a learning curve. So they will get presented data, which by process they have then to somewhat review and give you permission to start with a novel technology, and later on, after 24 months or longer, becoming suitable technology. I think this data monitoring and the sharing of all the data for your products, this is also a part which is to the extent in practice not from Fraunhofer or pilot, any kind of EFSA opinion and petitions, but now really on active recycling in the field, in this pre-processing, processing chain I mentioned. It's also new for EFSA. I trust they can somewhat absolutely cope and comply to that and know also what is going on. But as I mentioned, those reports we are doing also with Fraunhofer, I think EFSA is at least not unhappy to get as much as possible data on cleaning efficiency, on decontamination, on recycling technologies, in order to value also those technologies on their way from novel to suitable technology, because this is new for everyone. Yeah.
Thank you.
Was it on your question? You smile. I mean, this, we can talk the afternoon here, but I'm not so sure if everyone, but this regulation and the impact, especially of a new one, is a challenge, I think, for all the participants, for the market players as well as for EFSA and the local competent authorities. It's rather new, and what we see is still that not everyone, as I said earlier very politely, not everyone has found its role, its responsibility, and maybe also what then has to be provided and shared on way forward. This is coming, I'm pretty sure, because we are getting into the market and it's highly important, but it's a new regime, and it's, I think, new for everyone, in a way, positively.